Hello everyone, my name is James Mooney and I am a digital preservation technical specialist working at the Bodleian Libraries, which is part of the University of Oxford. Today my presentation will be on how we proactively monitor our monolithic repository systems with a digital preservation microservices suite which we've developed in-house. So a little background, the Bodleian Libraries has multiple repositories which hold a variety of digital content, such as digital-born archives, research publications, and digitized facsimiles. These repositories lack many of the needed digital preservation actions we would now expect to see. We wanted to avoid duplicating all of the digital content into a new preservation system, which would be just yet another repository for us to manage. So in 2019, we undertook a review of various approaches to embed digital preservation actions into these existing repositories. This led to the development of our microservices framework, which we call DPMS, which is short for Digital Preservation Microservices. When developing this framework, our approach was to ensure that it operated independently from each of the repository's application layers and that it would access the files directly on the file system. It would also utilize existing infrastructure within the university wherever possible, and we would try and keep the development as simple as possible. We developed the DPMS platform using the following open source software. Rundeck provides us with an out-of-the-box graphical user interface solution for managing the automation of tasks involved in the running of the platform. And then Elasticsearch, which comprises of a number of components such as Elasticsearch, Logstash, and Kibana. This was used to import, index, and visualize data gathered from those repositories. And then Zabbix is our server monitoring solution, and we've utilized this to capture high-level statistics from the index data in Elasticsearch. Then Grafana provides us with yet another data visualization tool to display the high-level statistics which Zabbix captured. And finally, GitLab is used to track issues discovered within the repositories during day-to-day operations, as well as providing a source code version control system. When we planned the development of the DPMS platform, we decided to develop in 5 specific deployments. This meant that we could deliver parts of the solution to the end users as they were completed, and this allowed us to tweak the service as we went on based on the feedback from those users. The 5 deployments consist of file integrity monitoring. This scans all the files in all repositories to ensure that the content remains the same and that we can proactively detect additions, deletions, modifications, and corruption. Then we added virus scanning, which provides regular checks of the content after it's been ingested. We then developed the backup and restore analysis service, which looks to report on the nightly backups of the repositories, but also once a quarter restores the entire repository to scratch storage space where it is also scanned and it's compared with the live repository at a point in time. Next is characterization, where we identify the formats of files held in the repository, as well as extract technical metadata related to the files. And finally, validation confirms that the files stored comply with various standards and are valid forms of the file format. So let me describe the architecture of the DPMS platform. We start with a virtual machine which has Rundeck. Rundeck automates a number of tasks, one of which is our file integrity worker. This worker is designed to scan all the files from each repository using a read-only connector. It can use multiple CPU cores to allow for parallel processing of these file scans. The worker calculates a SHA-512 checksum for every file by default. For some of the repositories, the worker can also calculate additional checksums if needed, as these can be compared with the repository's own held checksums. As well as checksums, the worker also captures the basic file properties such as permissions, owner information, file size, and the last modified date timestamp. At the moment, we carry out this type of scan every month. All the information gathered by the worker is then written to a JSON log file. This log file is then ingested into our Elastic cluster, which is provided by the university. From there, the log file is indexed in Elasticsearch, and it then becomes what we like to call an event sequence, for example, 1. And then when a second log file is provided, this becomes event sequence 2. We can compare the differences with our comparison service and annotate the latest event sequence with those differences. We then use Zabbix to store high-level statistics gathered from Elasticsearch index, such as the number of files in the repository or how much space has been used by the files. Zabbix was already being used by the Bodleian to monitor all of the server infrastructure. Those high-level statistics can then be visualized in Grafana through a series of dashboards. For more details about a certain statistic, Grafana can then link to Kibana, another part of the Elastic Stack, to provide a more detailed report. So here's a quick demonstration of what the service looks like. This is the main dashboard for the service owner to review the current state of the repository. It's tracking how many files are in the repository, how much storage space is being used. For storage planning, we also provide details such as the average file size and how many files are under 1 kilobyte in size. We have a repository score value, which is an algorithm to highlight where there might be an issue within the system, such as files with a 0 file size or where files have changed since the last scan. Zabbix is able to provide projected storage values based on the previous scans, so we can see how much space might be needed in 3 months, 12 months, or 3 years' time. Parts of the dashboard can link to provide detailed breakdowns such as storage space. Here you can see how much data is stored in a certain collection or folder within a certain repository. The comparison of the previous scan allows us to see how many files have been added, deleted, or changed. And in this example, you can see that 34 files have been flagged as a fixity alert, meaning that the checksum from the previous scan doesn't match the current scan. Hovering over any element brings up help text, as well as a link to review statistics in more detail. If we click the link, we're taken to another report generated Kibana. Here we can see that MEX files have been edited, explaining why there is a fixity alert. Currently, the digital preservation team would look for changes between the scans and then would raise a GitLab issue ticket for the service owner to triage. On the dashboard, you can see we have an open GitLab ticket relating to those fixity alerts. Clicking the link would take the service owner to the GitLab ticket to comment on. Once an issue is resolved, the alerts can be annotated and cleared from Elasticsearch. Lower down the dashboard, you can see we have the results of the virus scanning provided by Sophos. Development of this platform is continuing, and so far we have file integrity monitoring, virus scanning, and backup and restore analysis completed. Each new deployment enhances the JSON log file that we send to Elasticsearch. We can then roll out new additions to the dashboard. We are currently working on the characterization deployment, and for now we have selected to use Seekfried for the file format identification, utilizing the pronom file signature database, and then EXIF and MediaInfo to provide technical metadata for audiovisual content. I hope that was interesting and provides you with a brief overview of just part of the digital preservation microservices that we have been developing. If you have any questions, please feel free to contact me on my email address, james.mooney@bodleian.ox.ac.uk. Thank you.